So everyone, as I go through these examples and I do the homework, I'm just going to be hitting this plus sign down here to create new tabs across the bottom. And then I'll just name these tabs with the name of the example or the homework problem that we are doing. So example 2, everyone, brings us, the table gives the amount of federal tax paid per person since the year 1970. I hate paying taxes. I pay a lot of them. So again, everyone, what I'm going to choose to do is just highlight everything in my table, go ahead and paste it somewhere in the spreadsheet, and it doesn't have to be somewhere like in the perfect upper corner here anywhere. It's not going to matter. And again, I do see right away that I know that I do not want this to be my x-axis values because they're way too big and it's going to make a really nasty equation. So I'm automatically going to insert a column to the left there, and we're going to do years since 1970. So years since 1970, 1970 is 0, 75 is 5. You see the pattern here. You got to be kind of careful though, because sometimes they skip a beat or something. All right, so now our x values will be much nicer, which will produce an equation that is much more usable. So we're asked to find a linear, quadratic, and cubic model that represents this data. And so remember, quadratic is a polynomial to the power of 2, and a cubic is a polynomial to the power of 3. So when I make my chart, everyone, I am again just going to get these two columns, not this one. We're going to say insert chart. And it's now default going to go to scatter chart because a scatter chart is the one that I used on the previous example. So with that, we do need to go to customize, series, come down to trend line. And remember, when I click trend line, there'll be another menu that appears down here. It automatically gives me the linear model, and we can see that the linear model doesn't really follow what's happening here very well at all. But to get the equation to show up on here, everyone, we do need to come down here to where it says label and say use equation. So our linear equation, quadratic, and cubic. We'll collect those three and put them there. So if I just click in there a couple times, I can copy that, paste it here. Again, to get this menu back up over here, I have to double tap inside the graph there. Again, I need to go to series. I don't want a linear equation this time. I want a polynomial to the power of 2. That's a quadratic. And it's already going to be having my equation shown there. So if I tap a couple times, I can get it, copy it and paste it. Double tap in here again, back to series. This time, I want a polynomial to the power of 3 because that's a cubic. So there we go. And so one thing I want to stress, everyone, is this is actually how people use data to make predictions about the future. You can see these equations are just like wicked nasty. And it's nothing for us to worry about because we're going to let the computer do all the work in deriving the equation, and then we're going to let Wolfram do the work in terms of solving it. So it's super helpful to be able to use technology to do this and in a meaningful way in real life. So what we've got is using the model that best fits the data, predict the federal tax per capita in the year 2020. And so let's go back through these again. I'm just going to change them and see what we think fits best. So I would say the polynomial to the power of 3 looks like it fits pretty darn close. Polynomial to the power of 2 is almost exactly like a straight line. And the linear one is a straight line. We can see that neither one of those really are the best fitting thing there, everyone. I see the polynomial to the power of 3 matching up with those points much better. So I'm going to use the cubic this time, which is the polynomial to the power of 3. We are asked to use that. And again, I could put a y equals here in front. To predict the tax per person in the year 2020. And so that's, come on, 2020 would be 50 years after 1970. So I'm going to end up adding a 50, or putting a 50 in for my x value. Don't forget to put the times symbol in here, everyone. On my keyboard, it's the star above the 8. So this model predicts that in 2020, the federal tax per capita is going to be $4,515. So part A. Federal tax in 2020, Toto, in 2020 would be, what was it, $4,515? Mm-hmm. Based upon cubic model. Maybe let's see what would happen if we use the quadratic model just for giggles. And so again, we are going to replace x with the value 50 because we are 50 years after 1970 in this instance, talking about the year 2020. And this is massively different. It predicts the federal tax per capita to be 9,637. 9637. Okay. And I'm not going to ask you to go ahead and do all these models, everyone, like the linear, the quadratic, the cubic. We chose the cubic because it was the best fit. I just did want to demonstrate that the quadratic or the cubic would have a different answer than the quadratic would. And so I'm not sure exactly which one of these is more accurate. I'll Google it in a moment and see what the federal tax paid was in 2020. Again, you could do the linear model if you want to. I'm not going to. And then in what year does your model predict that the federal tax per capita will reach $9,000? So since we already have the quadratic model in Wolfram here, we'll do the quadratic model. No, I'm going to go back to the cubic model. Okay, I can't go back. So let's just go ahead and do this, everyone. I'll get the quadratic. And again, we're going to be checking to see when is this equal to $9,000. And so like we've seen in previous things, we do have two solutions here. And so we would choose the first one in this instance. 46 years after 1970 is the year 2016. The quadratic model predicts $9,000 per capita federal tax in the year 2016. Our model also predicts that it would happen again in 421 years. So that's way too far out. We're not even going to pretend that makes any sense. And so the cubic, everyone, since we did do the cubic and the quadratic earlier, let's do that again. Let's see what the cubic does here. I bet it's going to be interesting. And so you'll notice, as with example 1, everyone, we do get imaginary solutions here, which means that there is no solution. So according to the cubic model, the federal tax per capita will never get to $9,000 per person. So according to the cubic model, federal tax will never reach the level of $9,000 per person. And I'm thinking now that I should have probably made this font larger to begin with. I will make sure I do that on all my examples and homework solutions later. So that's what we've got, everyone. Again, the reason it's never with the cubic is you can see that it tops out here. It doesn't even ever reach 8,000 and starts to come back down. And the way that we see that mathematically is that we get imaginary or complex solutions. So part C, that was part C actually. So I mislabeled these, everyone. That's part B. That's part C. Our part A was doing these equations right here, which we've got. So with that, everyone, that's it for this one. We'll be on to the next example in a moment.